radical equations, part 2, or the more complex ones. Let's say I have this one. Now you can tell already these were a lot more complex than the ones we were doing. You've got to get rid of the square root. So you're going to square both sides. But remember, you can't just individually square them with a plus or minus sign. You have to do the full method. So x squared plus 8x equals, so let's write it twice. So x squared plus 2x plus 2x plus 4. So x squared plus 8x, x squared plus 4x plus 4. And I know that y'all are thinking, what have you done? This is going to be a nightmare. Well, actually not as much as you think. Because notice how if you try to get the x squares to one side, they cancel. So then we're left with a basic equation. Subtract the 4x, so 4x equals 4. X actually equals 1. And when you try to plug it in, 1 squared plus 8 times 1 or 8. So square root of 9, 3 equals 1 plus 2, 3. So no extra answer. 1 is right. Oh, well, let's do another one. What about if there's 2 square roots? Something like this. Sadly, you can't just square each individual term. For the same reason, you can't do that up here. So, get the messiest one by itself. So, you're going to subtract that one over. So, square root of x plus 9 equals 9 minus square root of x. Square both sides. And I know I can hear you moaning already. X plus 9 equals 81 minus 9 square root of x minus 9 square root of x plus x. And it's fixing to get better. Because notice how if you try to get your x's together, they cancel. So we get 9 equals 81 minus 18 square root of x. Subtract the 81, so negative 72, negative 18. Divide by negative 18. So 4 equals square root of x. And so last step, square both sides. 16. And so let's check our original problem. Square root of 16 plus 9 or 25. So 5 plus square root of 16, 4. 9 equals 9. Yes. So 16 is a correct answer, or the correct answer. All right, let's do another one. Square root of x minus 3 minus square root of x equals 6. Notice how in this one, the same instance going to happen. There's more than one square root. So let's move over one of them, or in this case, to isolate the messiest one. So 6 plus square root of x. Just like before, we're going to square both sides. So 36 plus 6 square root of x plus 6 square root of x plus square root of x squared or x. Same thing. They cancel for us, which is nice. So we've got 12 square root of x. So subtract the 33. I'm sorry, subtract 36. So negative 39 equals 12 square root of x. Yep, you can tell I made this one up. But it's going to be okay. Divide by 12, so you get square root of x equals negative 39 over 12, or a little bit of below negative 3. Well, the good news is, what do you know when a square root by itself equals a negative? No solution. So, let's do one more. They do like giving you one like this every once in a while. So same thing, square both sides. So x plus 5 equals x squared minus 7x minus 7x plus 49. So x plus 5 equals x squared minus 14x plus 49. Well, notice out of this case, the x's or x squared doesn't cancel. So it's like, oh no. Well, now we're going to have to revert to some Algebra 2. To get the x's on the same side and the numbers on the same side, we're going to have to solve by factoring. Well, technically you could do quadratic formula, but usually people don't want to do that. So, what multiplies to give you 44, adds to give you 15, and 11, and 4. So x equals 11 and 4. Now let's go back in the original. Square root of x plus 5 equals x minus 7. When we plug in 11, square root of 16, or 4 equals 11 minus 7. So 11 is good. Now let's plug in 4. 4 plus 5, square root of 9, or 3, equals 4 minus 7, negative 3. Doesn't work. Only the 11. Hope that was of help to you. Have a great day.